Alright, welcome back. This is our third video in this section. We've talked a lot about how to manipulate things that are inside radical signs. So, the last piece of the puzzle is when you have something like this that we want to simplify. So these are the last four examples in the notes that we're going to do in this video. We want to simplify 4 over the square root of 5. And at first glance, it may seem that there's not much you can do there. Normally we'd want to break down 5 and see what maybe we can pull out, but 5 is just 5 times 1. There's nothing we're going to be able to do there. So what is there to simplify? Well, see, the thing is, mathematicians are very particular about some things, and one of the things that we're not allowed to have is a radical sign in the bottom of a fraction. That is just not allowed. Okay, the bottom of a fraction is very special. It's never allowed to be 0 because bad things happen if the bottom of a fraction is 0. And we don't want there to be roots or radical signs down there. Okay, we want that to be a whole number. So we have to find a way to get this square root of 5 on the bottom to be a whole number somehow. Well, probably the easiest way to get something under a square root to become a whole number is to multiply it by itself. What if we took this square root of 5 and multiplied it by the square root of 5? What is the square root of 5 times the square root of 5? Well, remember from our rules, if we have two things in square roots and we multiply them together, we actually multiply the numbers inside. That becomes the square root of 25, which would just be 5. So that's what would happen on the bottom of the fraction. See, by multiplying it by itself, it becomes a whole number. The question is, what can we do on the top? Can we just keep this a 4 all the way across? The answer is no. I'm sure you've done this in the past, several years ago. Okay? Anything you do to the bottom of a fraction, you have to do to the top. So if we're going to multiply on the bottom by the square root of 5, we've got to do the same thing up here and multiply by the square root of 5. Okay? So on the bottom, we know these two things multiplied together makes 5. But on the top, we have a 4 outside of a root and a 5 inside. And we are multiplying these two things, but since this is outside and this is inside, we can't put them together somehow, so we'll just squish them. Okay? This is just 4 square root of 5. And this is okay. I know this actually looks more complicated than what we started with, but the whole point is that we're not allowed to have these roots on the bottom, and because we did this, we don't have one on the bottom anymore. It's on the top. We'll never be able to get rid of both, at least if it's simplified. But that is what we end up with, and that is okay. So let's move on to the next one. I found out that I can use several colors on my board now. They're all darker colors, cool colors. I can't use red or orange. Those don't work well here. But I can do these. So let's see here. Let's use purple. Our next example here, we want to simplify the square root of 16 over 3. Let's see here. I'm just going to copy that down. I kind of gave things away just by writing this. I've written an equals sign here. And the reason I want to do that is because this example is a little different than this one. Here, just the bottom was under the square root. Here, the whole thing is. The top and the bottom are inside that root. So what we can do to start here, if you ever have the square root of a fraction, you can break it up as the square root of the numerator over the square root of the denominator. You're allowed to do that. So Anything you know here? It's still going to be a fraction. The square root of 16? Do you know what that is off the top of your head? So the number here will be whatever number, if you multiply it by itself, you get 16. That's 4. So the top here is just 4. And on the bottom, 3, you can't really break down at all. So the square root of 3, that's just what it is. So we've had to go through a step or two here to get to this point. Notice I haven't put a box around this, and I'm not going to because it's not our answer. What is wrong with this that we need to fix? Yeah, it's got a root on the bottom, just like what we started with here. So in this example, we had to actually go through a couple steps just to get to where we started here. So we'll start with this. And what are we going to do with that to get this root out of the bottom? We want to do something like we did over here. These square roots of 5 came from here. So whatever is on the bottom, that's what we're going to multiply by on the top and bottom. So this time it's going to be the square root of 3. Okay. This is still going to be a fraction. Make it a little bigger. Okay. On the top, we've just got 4 outside the root, 3 inside. Smush. 4 square root of 3. And on the bottom, the more problems like this you do, the easier it'll be to notice. You don't have to go through a whole lot of steps here. If you multiply the square root of something times itself, what it ends up being is just the number inside the root. So if we're multiplying the square root of 3 times itself, this should be 3. Okay. If you ever forget that, or you don't trust it for some reason, you can just multiply these 3's together and get the square root of 9. And then you could break that 9 down into 3 and 3. And since it's a square root, you circle 2 things at once. And that's just 3. You could go through all these steps, or you could see the pattern. Square root of something times itself is just the number that's inside. Okay, now we don't have a root on the bottom anymore, so again, that's what we have. All right. So hopefully, if I give you something to simplify that looks like this, I'm hoping you can see that this is what you'll need to do. Okay, this one was a little trickier, but if you can split top and bottom and find that one of them simplifies, or this didn't even have to simplify. You could have kept this as a root on the top if it didn't simplify, but that's okay. All right, let's move on to example 8a then. Okay, we still want to simplify something that's a fraction that has a root in it, but I do want you to notice right from the start, this is very different than either of these two. Look at the bottom of the fraction here. How many terms do we have? 1, 2. For these, there was only one term here. There are no plus or minus signs. Here we've got 7 minus the square root of 2. The fact that this has 2 terms is going to make it impossible for us to get rid of this root here just by multiplying by that root again, because this is more than just the square root of 2. So there is a different way of dealing with that. We still want to accomplish the same goal. We want to be able to write this expression without any roots in the bottom. So we need to be able to take this square root of 2 and somehow turn it into a whole number, preferably by multiplying by something, just like we did over here. But we can't just multiply by the square root of 2, because then this will have a square root of 2 with it. And that's not what we want. We need to find a way so that nothing on the bottom has any roots on it. And the best way to do that is to multiply the top and the bottom of this fraction by what's called the conjugate. Let me write that up here. Conjugate of the denominator. Okay, what is the conjugate of this? If you've got two terms down here, the conjugate is going to be exactly what this is, so 7 minus the square root of 2, but with the opposite sign in the middle. So instead of a minus sign here, we're going to change it to a plus sign. So the conjugate of 7 minus the square root of 2 is 7 plus the square root of 2. That's what we're going to multiply the top and bottom by. I know that doesn't seem like it will get rid of all the roots on the bottom, but something magical will happen here. So let's give it a shot. I'm going to go ahead and write the equal sign down here. I've not got enough room to the side here. So I'm just going to write what I have. Okay. This is still going to be a fraction. Let's just deal with the numerator first. What's on top? We're going to want to distribute this 3 into both of these terms. So 3 times 7, 21. 3 times the square root of 2, smush. That's going to be positive 3 square root of 2. And now on the bottom of the fraction, we've got 7 minus the square root of 2 times 7 plus the square root of 2. We've seen a problem like this in the last video. We're going to FOIL this out. Okay? The fact that it has roots here makes it a little interesting, but we can still do this. So, FOIL. Write yourself a note there to FOIL that if you think you might forget. We'll start with 7 times 7. That's going to be 49. The O of FOIL is outside. 7 times the square root of 2. Smush. That's going to be plus 7 square root of 2. I inside. This is negative square root of 2. That negative goes with this. Times 7. Okay? This is the same as what we just did on the outside, except it's negative. So we're going to have negative 7 square root of 2. Smush. Minus 7 square root of 2. I'm going to need this to be a little longer. And then L for last. We multiply negative square root of 2 times positive square root of 2. Negative times positive is going to be negative. The square root of 2 times itself. That's similar to what we've been doing on the bottom of these. Okay? The square root of 2 times itself is just 2. So minus 2. Okay. We are close. We are very close here. So, just to pause for right now and recap what we've done with this so far. We're simplifying this because it has a root on the bottom and we're trying to get rid of those. Since we have two terms down here, we're going to multiply the top and bottom by the conjugate of the bottom, which is this, but with the opposite sign in the middle. Okay? We wrote this out, distributed on top, FOILed on the bottom. Okay? We are very close. So let's see what we have here. Still going to be a fraction. I'm thinking of, at this point, like combining like terms. So we have 21 and 3 square root of 2 here. Those are not like terms. This doesn't have a square root with it. So on the top, I'm just going to copy what we have. Okay. But on the bottom, we should be able to do some things. What can we put together on the bottom? Well, the 49 and the minus 2. Neither of those have any roots. So we can do 49 minus 2. That's 47. Okay, and I might even yeet those out of existence since I've dealt with them now. Can these two things be put together? Do they have the same number inside the root? They do. So we can put these together. So what is 7 square root of 2 minus 7 square root of 2? Well, we're actually going to take the numbers on the outside. 7 minus 7 is 0, right? So this makes 0 square root of 2, which is just 0. So these cancel out entirely. This is just 47 down here. And so now you see, magically, by multiplying by the conjugate on the top and bottom and foiling it out, everything that had a root cancels with itself. And we're left with just a whole number down here. And it actually turns out that's our answer. There's nothing else we can do there. Nothing else to combine. I suppose you could split this up into 21 over 47 plus 3 square root of 2 over 47, but you don't need to do that. This is simplified. Okay? So there was a little more work that we did here, but again, as with most of the problems that we do in this class, I am most interested in the very first step of the problem. If you can get a problem like this and show me that you know to multiply the top and bottom by the conjugate, I'm pretty happy about that. After that, it's just arithmetic, essentially. Okay, I'm not super concerned about that. It's a little tricky at times, especially with the roots, but the conjugate idea is what I'm really after here. Okay, so let's tackle the last example. Maybe you're feeling adventurous. Maybe you're the type of student that when we go through a problem in class and then I ask you to work on the next one on your own, you are all over it. You really want to try it. This is a great problem to do that with because it's very similar to this one. See, we've got 2 terms here on the bottom of the fraction with a root there. You should be able to do it very similarly to how we did this. So if you're interested in trying that out, pause the video, give it a good shot. Don't take more than a minute or 2 on it, okay? I don't want you to spend an hour on this. Okay, but give it a shot. At least try and write down the first step. How are you going to start this? What's that first step? And we will go through it together in just a sec. All right, so we want to simplify this. We've got 2 terms down here on the bottom, and one of them has a root. So that tells us we need to multiply by the conjugate again. We're going to multiply by the same thing on top and bottom. So when the bottom was this, 7 minus the square root of 2, we changed the sign to a plus sign. This time, we're starting with a plus sign down here. So the conjugate is going to have a minus sign there. So we're going to be multiplying on the top and bottom by 3 minus the square root of 2. Okay. Do I have enough room here? I want to make it look like this one. I'll go down here. Okay, so let's just write what we have. 4 times 3 minus the square root of 2 on the top over 3 plus the square root of 2 times 3 minus the square root of 2. I get a habit of putting those parentheses in there because otherwise you might lose what's being multiplied. 4 is being multiplied by this entire thing. So we put it in parentheses. You don't have to write this step, but I would very much encourage you to do so. It's very easy to miss something if you don't write this step. All right. Let's tackle this. On the top, we distribute 4 times 3 is 12. 4 times negative square root of 2. We smush that together. That's negative 4 square root of 2. So that's what's on top. On the bottom, again, we are foiling here. So 3 times 3, that's the easy one, 9. 3 times negative square root of 2. We squish that together, but we put the minus sign in the front because it's negative 3 square root of 2. I'm going to need more room here. Okay. On the inside, positive square root of 2 times 3. Again, squish, that's positive 3 square root of 2. And then that L for last, positive square root of 2 times negative square root of 2. Positive times negative is negative. Square root of 2 times square root of 2. That's the same thing that we did here. That just became 2. So minus 2. Okay. So this is what we have. Okay. If you weren't sure how to get down this far originally, now you can write all this down. So we're here. See if you can simplify it and put the like terms together. I want to see if you can get the answer from here, even if you were kind of lost up to here. So if you haven't, pause the video, combine the like terms the way you should, and see what you come up with. We ready? Let's do it. On the top, 12 minus 4 square root of 2. These are not like terms. You can't put these together in any way, so we're just going to copy it the way it is. So 12 minus 4 square root of 2. On the bottom, we combine like terms where we can. I see a 9 and a minus 2 that don't have any roots. So we can combine those. 9 minus 2 is 7. Cancel those out. Okay, we've dealt with them already. We have negative 3 square root of 2 and positive 3 square root of 2. We can combine these because they've got the same root. Negative 3 plus 3. Again, we see that these cancel each other out entirely. And that is exactly what we expected to happen, because the whole point of multiplying by the conjugate is so that these terms would cancel out. So this is 7, but I'm going to write it more centered there. All we have on the bottom is 7. And that's what we end up with. Okay. This process that we've talked about in these 4 examples, where we have a root on the bottom and we want to get rid of it, that process is called rationalizing the denominator. Okay? We're taking the denominator of the fraction that has a root, and we're turning it into a rational number. Because right now it's irrational. Okay? So we're turning the denominator into a rational number without a root. Okay? You don't need to know this necessarily, but just in case sometime later on in your academic career you hear someone say this, maybe that bell will go off in your head. I've heard that before. And then you can think about the words. Denominator is the bottom of a fraction. Rationalizing, we're turning it into a rational number that doesn't have a root in it. Okay? And we're doing this because it makes mathematicians happy, and since you're mathematicians in training, it's important to you too. So, I think you are ready. We've now talked about everything in the notes. You should be ready for the problem set for 6.5. If you've been taking good notes through these 3 videos, you've got everything you need. The assignment has 5 questions on it. 5 questions. And most of or all of those questions have to do with the first 2 videos. I'm not sure there are any where you have to rationalize the denominator like we have done here. So if this video was like over your head and you don't really get it, that's okay. Still try those problems out. You should be able to work through those. Okay. As always, if you have any questions, shoot me an email. I'm more than happy to help you out. I would really like to do so. But we're done with this section, and so I guess we'll see you next time in the next section. See ya.